My name is Shravan Kumar and this is my submission of proof for the mini project for the course CS2206 Computer Architecture Spring 2026. I'd like to state that this project is a product of my own hard work and dedication. Every design decision and every feature was built by me from the ground up with integrity and originality. After downloading the zip file, copy all the test programs into the same directory in which the ASM and emu files are present. Now, to run this, we use the command to compile all C++ program files. That is g++ file name -o and the executable file name. Now, I will demonstrate the process for the first program, that is bubble sort. All the following programs follow the same procedure. Now that the assembler file has been compiled, to use it, use the command /asm file name. As you can see, we have three files generated by the assembler. One is the object file, the listing file, and the log file. The log file has all the errors. The listing file has the machine code and the corresponding assembly code. And the object file is a binary file that we pass to the emulator for it to execute. Now, we compile the emulator using a similar command. And to use it, we need to give /emu and the file name and one or more of the three options that is being prompted, that is trace, before after, or memory dump. To demonstrate for the first program, I am giving all the three options together at once. All the following programs follow a similar method. As you can see, the halt has been reached and we got the three files in our left panel. The trace file shows a trace of all the instructions that is being executed. The before after file shows the register values before the instruction is executed and after the instruction is executed. The memory dump is a dump of all the values that is being stored in the memory. Any unused memory value is just being written as 0. As you can see, the sorted array is being stored from address 44 to 4b. Now, we use a similar method to assemble the factorial program and also to emulate the factorial object file. As you can see, the halt has been reached again with 297 instructions, and the trace file, the memory dump file, and also the before after file have been generated in the left panel. We assemble the Fibonacci.asm file in a similar manner. As you can see, since there are no errors, only the object file and the listing file have been generated. Now, we emulate the object file. The halt has been reached and the program has stopped emulating with 227 instructions generated. And as you can see in the left panel, the trace, memory dump, and before after files have been generated. In a similar way, we also assemble the palindrome program and emulate the palindrome object file. Again, the halt has been reached with the three files generated in the left panel, and the program has been executed with 515 instructions executed. The errors.asm contains all the possible errors on this simplex instruction set, and on assembling it, as you can see, the log file has been generated with all the errors being displayed. The set instruction has also been implemented and works accordingly. As you can see, the max label is set to 100, and when we are using it in line number 4, LDC max, the value of max, that is 100, is being used to compute the machine code for that instruction. As you can see, it emulates accordingly with no discrepancies. Now I will assemble and emulate the test programs given in the problem statement. The test1.asm is an ideal file with no errors. As you can see, the log file has not been generated since it has no errors. Whereas the test2.asm is filled with all possible errors, so the log file has been generated. And if there are any valid instructions present, only those instructions are being written in the object file. The test3.asm also works as expected. As you can see, the test4.asm has been assembled with no errors, and thus the log file has not been generated for this. Now, when we pass the object file to the emulator with all three options, the object file executes with 47,653 instructions executed, and the halt has been reached after that. As you can see in the memory dump, The 10 values of the 10th row in the Pascal's triangle have been stored at the result address as highlighted by the cursor. And on scrolling to the stack, in the program the stack pointer was initially set to address 1000 and the stack grew upward by decrementing by 3 in each iteration. Please refer the claims file for further details on all the test programs, the emulator, the assembler, and any other questions that may arise. Thank you.